Good afternoon, students. My name is Professor Surya Basti, working as an assistant professor in SIRTE Bhopal. Today, we are going to discuss the further basic properties of soil, in which we have studied void ratio, porosity, water content earlier. Then, in the previous video, we have covered all the three properties. Then, we are going to study the next remaining property, one of which is degree of saturation. Before discussing the degree of saturation, I am going to explain this three-phase system or idealized diagram of soil. Here, these terms VA, VW, VD denotes the volume of air, water, and solid respectively. Another side, these terms WA, WW, WD denotes the weight of air, water, and solid respectively. Now, if we see what is the degree of saturation, then it is the ratio of volume of water to volume of water. Simply, we can say volume of water divided by volume of void. As we know, volume of water is denoted by VW and volume of void is denoted by VV. So the formula is F is equal to VW upon VV. Earlier, as in previous video, we have also discussed what is the degree of saturation, what will be the degree of saturation if soil is dry. So in very common way, if soil is dry, that means all the voids are filled up with air only. That means there is no water. So from the very basic formula, we will conclude that the term VW will be 0 and the whole value will be 0. Hence, the value of S will be 0. Such kind of soil is called bone dry soil or dry soil. And another way, if the condition occurs that the volume of water becomes equal to volume of void, then the term S is equal to 1 will be there. So the conclusion is, if the value of S is equal to 0, the soil is called dry soil, and if the value of S is equal to 1, the soil is called fully saturated soil. But if the value varies from 0 to 1 or between 0 to 1, then the soil will be called as partially saturated soil. That means the value of degree of saturation can be 0 or 1, or it can be within the range of 0 to 1. Now, the fifth parameter or the fifth basic property of soil is air content. Here, air content denotes the volume of air void to the volume of voids. That means how much amount of volume is there present in the, how much amount of air void present in the, with respect to volume of void. So, the formula will be VA divided by VD. Hence, we can also write VA in terms of VV minus VW. As from this basic formula, VV is VW plus VA. As we know, volume of void is a combination of volume of water plus volume of air. Then the volume of air will be VV minus VW. From here, we can calculate VV minus VW divided by VB, and by further calculation, we will have the formula is VV minus VW upon VB, 1 minus VW upon VB. Then, as we know, VW upon VB is degree of saturation. So, we can also find the relation between air content and degree of saturation. This is a mathematical calculation from where we could find out the air contained and degree of saturation has some relation, that is AC plus S is equal to 1. Now the term comes percentage air void. It is denoted by Na, which is the ratio of volume of air divided by total volume into 100. And this varies from 0 to 100%, but it cannot be 100%. That means the value will be less than 100%. What does it mean? That means a volume of air cannot be equal to the whole volume of soil. That means there's no soil. The soil is not existing anymore. That means the value of percentage air void cannot be equal to 1 or 100%. Now, the relation between air contained and void ratio. As we know, the value of air contained Na is equal to V upon V. If we multiply and divide VV, then we know VA upon VV, volume of air divided by volume of void, is air contained. And volume of void divided by total volume is porosity. So the formula comes, or the relation comes, Na is equal to AC into porosity. Now the next definition is specific gravity. Specific gravity is denoted by G, which is the ratio of weight of soil solids of a given volume, which is denoted by WD, to weight of water of some value, that is WW. Generally, its value is 2.6 to 2.9 for inorganic soil particles. Now, we are going to discuss another term, that is weight, unit weight. In case of soil, the unit weight can be of like bulk unit weight, dry unit weight, saturated unit weight, submerged unit weight. The formula for the bulk unit weight is, as the unit weight is denoted by gamma, the bulk unit weight is weight upon volume, the total weight upon total volume. Dry unit weight is dry weight upon volume. Saturated unit weight is the weight of the term, upper term is variable, but the volume is constant in every formula, as you can see. And the submerged unit weight is, it is also denoted by gamma dash, gamma submerged, which is gamma saturated minus gamma. So further properties will be discussed in other class. So have a nice day. Thank you, class.